Okay, this is Chapter 7, Section 7, and we're going to be multiplying and dividing algebraic expressions. So earlier we learned that only like algebraic terms, those with the same literal part, can be added or subtracted. However, any two terms, like or unlike, can be multiplied. To multiply two terms such as 2x and 3xy, first remember that 2x means 2 times x. Second, recall from arithmetic that the order in which you do multiplication, it doesn't make a difference. We've got two examples here. The first example says to do a times 2a. Well, I like to put the number in the front. So I'm going to move my 2, and then I group the things that are alike. So a times a, and whenever you're multiplying things that have the same base, they're both a's. This is a to the first, this is a to the first. You just add the exponent. So a to the 1 plus 1, which would get you 2a squared. Okay, on this one, I like to group the things that the numbers first, so I would say, okay, this is really 2 times 3, and then we've got an x squared here times x, and that x is raised to the first power if there's no exponent there, and then I've also got a y to the first. Okay, so 2 times 3 would give me 6. X squared times x to the first, well, you would add the exponent, so 2 plus 1 would give you 3. And then we've got y to the first. Okay, now we've added a little bit, made it a little bit more complicated. When we're multiplying these two things, we're going to put the 3 and the 2 in the front. Then I'm going to do x squared, and the other x I have is just an x to the first. Then I've got a y here, and that's going to be a y to the first, and then I've got another y, so y to the first, and then I've got this y over here, which is also y to the first. And then I've also got a z. Okay, so and that's going to be z to the first power. So 3 times 2, that's going to give me 6. X squared times x to the first, I would do 2 plus 1 and get 3. Y to the first times y to the first would be y to the second, and then we've got our z to the first power, and we don't usually write that. So that's going to be the answer to that example. As you did the preceding problems, you may have noticed that when you multiply like factors together, you actually add their exponents. So this is a rule: to multiply numbers written in exponential form having the same base, you're going to add the exponents. Hey, how are you? I'm good. So we've got some more examples down here, and I've got x squared times x to the third. So when they're saying the base is the same, they're referring to x. So they're going to add the 2 and the 3, and they get x to the 5th. So on this next one, we've got both of our bases to be 3. And so we're going to do 5 plus 2, add those two together, and get 7. So remember that we're going to put our 2 and our 8 together, 2 times 8. Then they put their a to the 6th and then a to the 5th. So a to the 6th, a to the 1st, this one would have been our a to the 1st, times a to the 5th. And they added the 6 and the 1 and the 5, which got them, and they multiplied their 2 times their 8, right? 2 times 8 gets you 16, and then a to the 6 plus 1 plus 5 got us a to the 12th. Notice in part B that the like bases remain unchanged when you multiply. That is, when you're multiplying 3 to the 5th times 3 squared, you add the 5 and the 2 to get the 7, but you don't multiply 3 times 3 and get 9. Okay? Exponents are added during multiplication, but numerical factors are multiplied as usual. When we divide exponents, or when we divide a to the 5th by a squared, well, a to the 5th means a times a times a times a times a. You got 5 a's on the top. A squared is 2 a's on the bottom. Well, you can see that 2 of these are going to cancel out. So we've got a to the 3rd on the top. Because we did 5 minus 2, we get a to the 3rd. So when we're dividing, we're not going to multiply the exponents. When we're dividing, it's different than multiplying, because we multiply, we add the exponents. When we divide, we subtract. So there's a rule that if you're to divide numbers written in exponential form having the same base, you're going to subtract the exponents. So some examples here. So if you see, we both got bases of x, so we just do 7 minus 3 to get x to the 4th. We've both got bases of 4 on this one, and so we would do 5 minus 2 to get our 4 to the 3rd. Now on this one, you got to be careful. We can deal with our base that's a and do 6 minus 3 and get a to the 3rd, but you still have to divide these numbers in the front. So 6 divided by 2 gives us 3. 24 divided by negative 6 gives us negative 4. M to the 7th over m squared, we're going to do 7 minus 2 to get m to the 5th. N to the 4th over n to the 1st, we're going to do 4 minus 1 to get n to the 3rd. So make sure you're careful with multiplication, like the like bases remain unchanged when dividing. This is especially important to keep in mind when the base is a number, as in part B of the previous example. When dividing expressions that can contain both exponential expressions and numerical factors, subtract the exponents but divide the numerical factors. For part C of the previous example. Okay, so we've got this rule here that says a to the 0 power is equal to 1. In fact, anything to the 0 power is going to be 1. So when you see that, I'll just give you some other examples, but if I had 3 to the 0 power, it's going to be 1. X to the 0 power, 1. 1,000 to the 0 power is going to be 1. Okay, so anything to the 0 power is going to be 1. Now, let's talk about negative exponents real quick. If we apply the division rule to a problem in which the divisor has a larger exponent than the dividend, the answer will contain a negative exponent. So we're still doing the same thing. We're going to say we've got bases of x here, and we're doing 4 minus 6, but that gives us x to the negative 2. So when you have that, you want to put that on the bottom. So on this example here, we're going to take our negative 12 divided by 4. Well, negative 12 divided by 4 is going to get you negative 3. And then if you'll look, we've got a to the 1st over a to the 5th, so we would do 1 minus 5, which is going to get me negative 3, a to the negative 4. This needs to go on the bottom of the fraction. When you have a negative exponent, you want to move it to the bottom, and that gets rid of the negative. So a to the 4th. Okay. This is the last example. The first thing we're going to do is focus on this 2 to the 8, 2 over 8. Well, we know 2 over 8 is just 1/4. Okay, now we've got m to the 6. We've got m to the 6 minus 3 and n to the 2 minus 3. Well, that's going to give me 1/4, m to the 3rd, and n to the negative 1st. So this n needs to go on the bottom with the 4, but the m, since it's positive, it can stay at the top with the 1. And you don't have to write the 1, but that would be the answer. So we're going to move our negative exponent to the bottom when we have it. We'll leave the positive exponent